Hello. Good morning, everyone. Welcome to the webinar on how engineers and scientists are moving beyond Excel. Couple of points. One, to listen to the audio, I've already left a message on the chat window for all the participants. To listen to the audio, you need to join the audio conference. So if you have a headset or a speaker, you should be able to listen to the voice part of the presentation. Point number two, if you have any questions, I'll take it up towards the end of my presentation. And please type your questions in the chat window. I will answer them towards the end of the presentation. Let's get started with the webinar. So the challenge that we are going to address in today's webinar is about whether you are working with Excel to do complex engineering and scientific calculations. And as you are doing it, would you like to do differential equations, statistics, optimization, 2D or 3D graphs, and signal processing in a simple way? Would you like to replace complex macros or C code with simple functions? You need to quickly process and visualize large data sets. Are you under the impression that these advanced solutions are unaffordable? And are you interested in upgrading to a powerful numerical analysis solution? If you are facing these challenges, we have a solution for you. Combining equivalence solutions with Scilab, we are providing an industrial-grade offering. Scilab is the world's most powerful open-source numerical computation platform, and Equalus is an exclusive provider of industrial-grade end-to-end training, migration, support, and consulting services. Now, customers can take advantage of our powerful open-source software without any of these risks. So, what's our advantage? It's a safe choice. There are over 3 million downloads. We have a global customer base. It is a stable and it's fifth-generation software suite, actively developed since 2003. It's fully featured. There are hundreds of complex mathematics functions, over 100 toolboxes, and industry-leading modeling and simulation capability is available in Xcos. And you have support. Equalus as a global support network, and with this network we provide a full range of training, support, deployment, and consulting services, and we have expertise at every stage of customer project cycle. Talking about development, it's very active, and we have a full-time dedicated team of developers. Hundreds of developers contribute through the Scilab Developer Zone, and we make 6 new releases every year. And there is no licensing hazard. It's a GPL-compatible open-source license. No licensing fee or licensing service to manage. You pay for services only as you need them. Low cost of ownership, about 90% less than purchasing equivalent software, and about 50% less than ongoing maintenance fee of equivalent software. And you can freely share your applications with customers or partners. Equalus was founded in March 2009 in Silicon Valley, California, with global partners, driving a vibrant online math community, which is at www.equalus.com, where members can connect, share, and solve problems together. Equalus is the exclusive partner of Scilab, a leading open-source platform for numerical computation. We provide full range of Scilab support programs for training, migration, email, phone support, video tutorials, knowledge base, and other premium features. We are an experienced team from industries such as Lockheed, GM, Lucent, Google, BAE, Halliburton, and train at local universities around Bay Area, from Santa Clara, Stanford, San Jose State University. Equalus is a network of global partners, as you can see on this map. And in India, you will find TechPassion. I'm from TechPassion. We are a 6-year-old company based in Chennai, serving automotive, space, and other industries. And we have extensive experience in providing solutions to customers using Scilab and Xcos. Equalus is one-third Facebook and two-third Red Hat for math. What do you mean by Facebook for math? It's a community of people who are interested in math. You can register for free and you can add information about yourself and join groups and forums. Whatever Red Hat does for Linux, we do for math. We provide a complete support package around new releases, including advanced documentation, video tutorials, training, and we can accelerate new product features and bug fixes. When you go to www.scilab.com, you will be welcomed by our homepage. And as you can see there, our message is we provide the most powerful, flexible numerical analysis, visualization, and simulation solutions for engineers and scientists at a fraction of the cost of other solutions, and it's built upon the world's leading open source numerical computation platform, Scilab, and it has been downloaded over 3 million times. It's a proven solution. How do you get Scilab? You go to our site and you can download Scilab. You can learn more about Equalus here. Scilab is available for Linux, Windows, and Mac. So, what is Scilab? It's a leading open source platform for numerical computation. It provides a very powerful computing environment for engineering and scientific applications. It was created by India in 2003. India is the French National Institute for Research in Computer Science and Control. There are many applications of Scilab in signal processing, control systems, numerical optimization, test and measurement, fluid dynamics, embedded software, to name a few. And it supports a wide variety of industries, ranging from aerospace, automotive, energy, high-tech, defense, finance, chemistry, biology. And we provide a broad platform coverage, Windows, Mac, and Linux. And you see the list of some of our customers. Next few slides, I'm going to talk about a few of our customers who have had phenomenal success using our solution. Peugeot is a French automotive manufacturer, and they were working on understanding the noise in passenger compartment. To do that, they used Scilab to build a tool where they wanted to take their simulation model and test data and correlate the data and optimize the design to reduce the noise. Value is a auto component manufacturer, and they are using Scilab for developing reliable modeling of thermal loading and electronics hardware in some of their products. They are using Scilab for developing, again, automation tools for rapid testing, which will help improve the life cycle of hardware. This is a success story from the semiconductor industry. They wanted to create or simulate data channels to study signal transmission. They use Scilab to build an automation tool, and the simulations are based on TDR and TDT measurements of data channels. IDT is another example from the high-tech industry, and they specialize in developing application-optimized mixed signal solutions. And they wanted to automate the testing of semiconductors for customer evaluation. Scilab solution, we analyze test data, visualization of results, and to analyze data characteristics. What are the key components of Scilab? At a very high level, Scilab has hundreds of bash functions. It's a high-level programming language. You can use it for 2D and 3D graphics, and it can interface with other devices. A lot of advanced modules, example Xcos for simulation. And the installation of these modules is handled through Atom, which is automatic module manager for Scilab. Scilab has been used for a host of applications. As is listed here, a few of them are signal processing, control, numerical optimization, test and measurement, fluid dynamics, and embedded software. It has a very intuitive user interface, and you can use it for rapid algorithm development and implementation. And it has direct import-export capability with Excel, and simple and fast mathematical matrix operations of entire data sheets. If you look into advanced modules in Scilab, there are modules for signal processing, for control systems, algorithm development, test and measurement, embedded systems, and designing mechatronic systems. I have listed some of the toolboxes of Scilab against the specific application domain. So if you look at numerical, Scilab toolboxes that are available are symbolic computing, statistic, rand line, tick box. Then for simulation, it's code generator. For optimization, quadratic programming, Quattro, MinCon, artificial neural network toolbox, and PVM toolbox. And for communication, we have OPC serial port, hard toolbox, DDE toolbox, and socket. And for compiling, you have Scilab to C, and the spreadsheet XLS link in Scilab_XLL. And for signal processing, there is a SIVP, IPD, and SIP, which will help you analyze all kinds of signals like electronic, video data, and image processing can be done using these toolboxes. And for control systems design, development, and deployment, there is computer-aided control systems design toolbox and other toolboxes for database handling with fuzzy SQL, and there is a toolbox for aerospace modeling called Scilab. In a nutshell, we offer more functionality, more flexibility, and less cost compared to other perpetual license apps or Excel. Another very important aspect is we constantly listen to the customer, and the voice of customer is incorporated into the product roadmap. And it's a product which is under active development, and we do 6 releases every year. Whether it is a toolbox or an improvement in XCOS, priority bug fixes, compatibility for operating systems, addition of new features, or a whole new idea, you can get it all into future versions of Scilab by communicating it to us. Equaless provides fast-start application training. We help with deployment and program or code migration, real-time support and online knowledge database, and we help our customers in special projects, consulting, and development. When you look at our SOS or Scilab online support portal, there is a lot of documentation. Video tutorials are available. You can ask an expert. There are tips and knowledge base, there are frequently asked questions, and many use cases. Scilab includes use cases for all key capabilities, housed rather than just a feature list. And they are available in both HTML and PDF form and over 1,000 pages. And the great thing is it's fully searchable. There are video tutorials available in English. And when you talk about live support, we offer chat, phone, email, and desktop sharing with our local teams. So there are custom functions that are available only for our SOS subscribers. So for dynamic link sticks, Excel, premium export options, finite element functions, computation accelerator with up to 1000x speed boost, and connections to databases such as MySQL, advanced GUI building templates, and new functions and blocks added all the time. When you talk about Equaless SOS support programs, there is SOS Education for students and faculty, SOS Pro for industrial users, SOS Pro Plus for industrial power users, and SOS Enterprise. These are for industry teams, and we offer bundles of 10 users with discounts, which include training, migration, and Pro Plus. When you go to our site and you hit on the contact page, you'll see a dashboard which looks like this. And I'm talking about Chennai in India. Right now, if you go to the India section, you will find this live chat to be green. So you click there, talk to our agent if you are on our support, if you are under support subscription. We provide support. We provide a range of real-time support options for immediate solutions, online knowledge base for optimal problem solving, and feedback into product roadmap for strategic alignment, and priority bug fixes for reliable performance. Now I'm going to go into the technical part of my presentation, where I'm going to give a product summary of Scilab and some demonstrations. So what do we have lined up for you today? I'm going to talk about Scilab, how the interface looks, how do you install a toolbox using Atoms, what are the basic functions in Scilab, what are the graph tools, optimization tools, what are the tools for solving differential equations, and for regression, and we have more advanced use cases for post-processing of data sets, and the principal component analysis. I'm going to show these two in the live demonstration. And other key aspects of Scilab, the XCOS simulation package and the graphical user interface capabilities. Something that I've been telling throughout my presentation is Scilab is a numerical computation platform, and it has a matrix-based syntax, a very easy-to-use interface, and a familiar, intuitive programming language. You don't need to do any compiling. You don't need to add interfaces to install. Large suite of toolboxes instantly available, and we have a dedicated team of professional developers making 6 releases every year. If you look at Scilab console, there is a variable browser, there is a command window, there is a history browser, and an editor window. How do you get the modules or toolboxes in Scilab? You use atoms. So when you look at the Scilab console on the top, you look at the icon, which is marked here, you click on that, you get a GUI, which lists all the modules that are available in Scilab and what you would have already installed in your computer. Say, for example, in this computer, I already have this MINW toolbox, image processing design toolbox, SIVP, OPC client, and socket already installed. That's shown on the right side. And on the left, I have this whole gamut of toolboxes that are available, which I want to install. I can go ahead and install. So how do I install? Say I want to install the image processing design toolbox. Scilab image and video processing toolbox. I select that and I get this option of installing. I click on the install button and it's done. So moving on, talking about the capabilities of Scilab to work with what you would normally do with Excel. You do a lot of data analysis and visualization using Excel. So how can you use Scilab to do those same tasks? You can do data import and export using simple commands. And what are the data types available? XLS, text, CSV, XML, binary, math, etc. And for data size up to 2 GB of memory, we are talking about a 16384 by 16384 dense matrix of doubles. That's a huge data set. And you can perform various matrix-based syntax to the entire data set. And it is simple and fast. Let me take a few simple examples. Say you want to create a big matrix of random numbers in Excel. There are 2 ways in which you would typically do. You go type in one column, say in one of the cells, equal to rand of parentheses. And you drag the corner for repeating the process, right? And you don't want to do this for a big matrix. The other thing is you would go write a macro. It's too much trouble for a simple task as creating a matrix of random numbers. Believe me, it's really simple to do. If you take Scilab, use the function rand of 500 by 500, the matrix is created. That's it. It's as simple as that. What does it mean for your productivity? Let's say matrix multiplication. Can you do this with Excel? Yes. How do you do it? You're going to follow at least these 3 steps. You select the cells to put B. Then you type this command MULT, bracket of range of A, range of X. And in Excel, the view would look like what you have here. This set of cells where I have defined A, I defined X, and I'm multiplying them to get B. Now, in Scilab, it's as simple as just saying A star X. That's it. Third function, you want to invert X. Number 1, in Excel you can go only up to 51 by 51. And you can handle only square matrices. In Scilab you can invert large matrices, and for square matrices you have inverse of A, and for non-square matrices you have P inverse or pseudo inverse A. A column vector of 100 students' exam scores. You obtain mean, median, maximum, minimum, and histogram. Graphing 2D, 3D. Scilab is a huge assortment of graphic capabilities. Large 2D and 3D plotting library. You can do 2D graphics, special control systems, signal processing graphs, MATLAB plotting emulation toolbox. Plotting 2D graphs, what you have on the top left, whole zero plots top right, bottom left plot 3D, bottom right plotting vector fields. Another huge area where you may be using Excel is optimization. here Scilab has some very neat and exhaustive list of toolboxes that you can use for doing the same task more efficiently. There is optimization and simulation toolbox. There is Quapro for quadratic programming, unconstrained optimization, Psychobyla, derivative-free nonlinear constraint optimization, and you have a Markov decision processes toolbox and iterative optimization algorithms from a book by Physically, and other toolboxes for unconstrained global optimization of polynomial functions, and many others. Say you want to solve an NP or linear programming problem using Excel. You can use a solver for a small system. You can buy other add-in software for larger systems. In Scilab, it's built for even large systems. Say you want to solve a 50 linear equality constraints and 1,000 unknowns. Say minimize C transpose X subject to A X equal to B. All you need to do is X is equal to the marker of A, B, C, X naught. To solve differential equations, Scilab has toolboxes to support these capabilities, and they are well integrated with XCOS and computer-aided control systems in that toolbox. Let's take an example problem. Tan of dy by dt equal to minus y plus 10t cos 3t with an initial condition where y is 0 or time 0, and the initial value of the derivative, that is dy by dt as to 0 is n pi, where n is 0 or 1 or 2. So for these three initial conditions, and I want to find what is y as a function of time, that evolution of y as a function of time is plotted in these graphs. And the picture on the left shows the few lines that's all it takes to write a Scilab program to solve a differential equation, what you have on this slide. Moving on to data analysis. You may want to do statistics, you want to do some spreadsheet processing, some input-output functions, CSV read-write, there is NAND toolbox, there is tickbox, artificial neural networks toolbox, Scilab JSON toolbox, OPC client, socket, and others. Let's take an example of regression analysis. So you have a set of data and you want to fit the best fit code. So the problem is you want to minimize the cost function given by the norm of, say, the difference between the data and the model, and you want to use the least squares condition. Here, one model that we have taken is A sin t plus bt, and there you get R as 0.75. And the other model, which is marked in green, is a polynomial model where f of t is a function of t, a fifth degree polynomial, and R is 0.71. Say you want to do some post-processing. So you have measured data, you want to use Scilab to visualize the data, you want to analyze, you want to do some post-processing, you want to build mathematical models, and then you want to export the post-processed data. And Scilab provides an integrated set of toolboxes for signal processing tasks such as time frequency toolbox, there is Scilab wavelet toolbox, there is linear system inversion toolbox, and empirical mode decomposition toolbox, IIR filters, image processing and design toolbox, and video processing toolbox, microwave, and sound file toolbox, artificial neural network toolbox, there is signal processing and XCOS. So I want to do denoising. I want to read a data set, CSV file containing two columns. One column contains time stamps, the other column contains the values. Here you have a sampling frequency of 1000 of. For visualizing the sample set in time domain, or computing the FFT of the signal to visualize it, then you want to construct filter, applying to the sample, and visualize the denoise signal, and save the denoise signal in CSV format. Let's see how to do these tasks. So I want to take a CSV file. This is like a screenshot from an Excel file which contains this timestamp in column A and the values that each of these units of time in column B. So to read in Scilab, it's just like 2 lines of program. Read underscore CSV, I need to mention the file name. Then eval them. So this takes all these values and stores it in a variable where one column is time, the other column is the value. Now I want to plot the data, so I define time axis, I define the amplitude axis, and I want to plot t, x. So amplitude as a function of time. This is the signal that we had in the Excel sheet, which we are plotting now using Scilab's 2D graphics plotting function. Now I want to calculate Fourier transform of this data. So I calculate the length of the array, and there is a ready-made function built in Scilab to calculate Fourier transform, FFT of x, and then over L, and I define the time rate. I want to plot frequency versus the absolute value, because when you calculate Fourier transform, even if it's a complex number, I want to plot the absolute value. So this is the Fourier transform, which gives the frequency content of the signal that we started out with. Now, I want to take that data, do denoising using a finite impulse response filter. So this shows the line function that's built in Scilab to build finite impulse response filters, and the parameters, which are the input and output of this finite impulse response filter function built in Scilab. So low pass filter with cutoff frequency of 3 and Hamming window. This is the original signal, and this is after denoising it. So a lot of the noise is out of the window. Now I have a clean data. So M is what we started with. M new is after filtering. Now I want to take it back to Excel. So to recap, we started with an Excel file, which was a CSV file. We read it in Scilab. Then we used the FIR filter. We plotted it. We plotted the FFT of the signal. We did some filtering function. We constructed a filter in Scilab. Then we have a denoise signal which we bring back to Excel. So using Excel and Scilab, you can harness the functions of the Scilab and do a lot, and in a very productive way. Another example that I want to show you next is principal component analysis. It's a mathematical method. So suppose I have a set of variables which are correlated, and I want to transform them into a smaller number of uncorrelated variables, and these uncorrelated variables are referred to as principal components. And it's suitable for datasets in high dimension, and it's used frequently in pattern recognition and for compressing data. Say I have this Fisher's iris data, which is essentially 50 samples from 3 species of iris flowers: Iris setosa, Iris virginica, and Iris versicolor. And the 4 attributes that we have for these samples are sepal length, sepal width, petal length, and petal width. And you read the data, and we can perform principal component analysis. It's as simple as this one line of program which has a built-in function in Scilab for doing principal component analysis. So this gives me the principal components, and we want to plot it, say the PC1, PC2, PC3 for these iris flower species. This shows the PCA plots for the 3 species: Iris setosa, Iris versicolor, and Iris virginica. They are marked respectively in blue, red, and green. So this shows only the PC1 and PC2, and you get a 3D where the principal component 3 is also shown for each of these 3 species. Those 2 demonstrations, one on reading data from an Excel file, plotting FFTs, doing denoising, and the second example on principal component analysis on iris flower species data, I'll show them as live demonstrations by taking the Scilab programs and performing the simulations in real time. Before we go to demonstrations, I want to show a few more cases in the Scilab. One of the toolboxes which is very powerful in Scilab and that's similar to Simulink and LabVIEW is XCOS. And say I have a water tank model that I want to build using XCOS to simulate and understand the behavior. I can build a model like this. As you would observe, you are not writing a script-based program, you're building a model which is very intuitive. The program gets automatically generated in the background. And you can build super plots. What I mean is, so right here, this is our time model. Hidden in this is another model. So this helps to compress the size of the model, typically when you're building a very complex dynamic model. Another toolbox in Scilab is lets the user build a graphical user interface. And Scilab has GUI, it's built in baseline Scilab, and there are special toolboxes for GUI building, and you can interface with external GUI via APIs, and you can interface with external code, and then all the major GUI elements are supported. They have list boxes, text boxes, menus, frames, pop-up menus, sliders, radio buttons, checkboxes, push buttons, and so on. This is one example where I want to take a data file and plot it. So the picture on the left shows the GUI that you would use. There are three buttons. One, when you click load data file, you can select a file that's shown under file information. Then file variables are shown at the bottom. And say you want to plot it, you click on the plot button. And say you want to load another data file, you clear and then load the data file, plot, and so on. Plot would look similar to what is shown on the right for the example data that I have loaded in an XY plot. Summary, you can easily import, export large data sets, almost any size, and you can do simple computation, you can post-process data using various functions, you can perform matrix operations. Scilab gives identical numerical results to other mathematics software, and it uses industry-standard numerical libraries, and a wide assortment of toolboxes are available in Scilab, and they meet all the requirements. Scilab has many baseline and external features to support data analysis. So what are the benefits? Scilab supports complex engineering and scientific calculations. Scilab provides advanced graphics. Scilab includes complete programming environment. Scilab supports large data sets with fast analysis and visualization. Scilab readily imports and exports Excel data sets. And no more license fees. Scilab is open source. No more maintenance fee. It's regularly updated by dedicated developers. No more toolbox fee. Hundreds of toolboxes available. And it's right out of the box. You don't need any previous programming knowledge. You don't need to learn compiling, simple GUI-based program. And easy updates and toolbox installation, and we provide complete documentation. Going back to Excel, you can easily import data from Excel, and there are functions for doing visualization, and there is access to hundreds of toolboxes that are in Scilab to use for manipulating your data, which you can otherwise do within Excel. And there are many examples that we have which helps you make progress on your problems immediately. It's a unique open source opportunity. Other open source solutions have little or no support, and Equalys is the official worldwide support partner for Scilab. We at Equalys are dedicated to making your switch to open source computing as easy and efficient as possible. And we are providing Jumpstart web-based training. It's only like $495 per student, and it's a limited time offer. And training is completed by July 6, 2011. How do you sign up? You go to www.equalys.com. Let me switch gears right now and show you some demonstrations. For that, I need to get Scilab on. There are two programs. So the first one is a signal processing example that I showed you, where, so in this directory, I've got the signalx.csv, essentially an Excel file. So this has got two columns. In one column I've got time, and in the other column I've got amplitude values. So this is the data that we have. So let's see what we can do with Scilab. Right? with the same data. So I can import this data into Scilab and do some processing, which is what I'm going to do today. So this is my function, right? So I'm going to read that file signalx.csv which you just saw, assign it to a variable n, and then I want to visualize the sample set in time domain, and I want to compute the Fourier transform of the signal and visualize it. So that's these lines of program do that. The fourth part is I want to construct a finite impulse response filter, apply to the sample to do denoising, and visualize the denoise signal. Save the denoise signal data in CSV format. So let me execute this program. So we saw the plots in Excel versus here. So this is my signal, amplitude versus time. This is the Fourier transform of the signal, amplitude of YFF. So this shows the frequency content of the signal. And now I've done denoising. The original signal I have denoising. It's obvious that a lot of the noise from the signal has been removed. So there you go. So this is one very good example of what all you can do with Scilab, which you cannot do with Excel. Moving on to my next example on principal component analysis. So this is the iris flower tree species data. We started with the attributes which look uncorrelated. We take them and find the principal components. Okay. So we read the data set and then we perform principal component analysis. We do the analysis and we visualize by plotting the data. We execute this data. So I have taken snapshots from this output plots and I have put it in my slides and I have just shown you. We have seen this already, so now I am showing it live. So this is principal component 1, principal component 2, principal component 3, principal component 4. The variance is plotted here. So here we have a scatter plot of PC1 versus PC2 for these three species. Iris setosa shown in blue here, Iris versicolor shown in red, and Iris virginica shown in green. And the same thing in a 3D plot would look something like this. And so on. Yeah, so this brings me to a completion of my demonstration of what programs that I have shown as part of my presentation. And we can take a few more questions before we come to the end of this webinar. Like I said at the beginning of the webinar, if you have any questions, you can go to the chat window and type a question. I will answer them now. Okay, so one question is it direct or the CSV read or XLS read functions, are they directly built in Scilab? Yes and no. The basic Scilab that you download and install has some capabilities for directly reading Excel sheets. On top of that, if you want to harness all the functions, you can go install the XLS link toolboxes that, like I said, to install any toolbox, all you need to do is, let me just show it quickly. Go to the Scilab console. When you click on atoms, To install a toolbox, you need to be connected to the internet. And when you click on Atoms, you will get a GUI, which is similar to what is on this slide here. So I clicked on that. I would this GUI, which is main categories and Atoms, and it will show the toolboxes that are already installed on the right and the toolboxes that are available and you could install if you want on the left. And then you can go select the toolbox for handling Excel sheets, and after that all the functions are available for you. So there you go. Say on this computer from which I am making this presentation, I have a set of modules that are already installed, which is shown on the right. So XLS link I already have. Suppose I don't have it, I'll go find it here. So I have XLS link here, I already installed it. If not, I can go install it here. Right? And after that, the functions from the XLS link will be available. And after that, you can use Scilab for taking Excel data and do post-processing. And like I said during the webinar, there are many advantages to taking that approach than doing the same processing in Excel, which could be cumbersome. So another question, the finite impulse response filter that I talked about, is a part of the XLS link. No, there are finite impulse response filter functions come as part of the signal processing toolbox. And again, you can install the signal processing toolbox by going to Atoms. And there are 4 types of signal processing toolbox that are available, depending on what your type of signal. If you're doing signal processing or image processing, video processing, there is signal processing toolbox. Then there is signal, image and video processing. There is SIVP toolbox. There is IPD toolbox, and then there is SIP. So these are the toolboxes that are available. I was using them for showing the example of signal processing. There the link with Excel is essentially the initial data comes from Excel and then final data goes back to Excel. Can we load multiple data files with a single command? Yes, that's possible. There are some examples available in the help. I suggest you can take a look at them. Or if not, I can send you some examples. We don't have any other questions. Thank you for attending the webinar, and we will have one more webinar in the month of July, and we will send you an email about that as well. And you have a good day. Thank you.